3.8, number 53. So let's read. It says, find the equation of all tangent lines at the given value. So at x equals 1, we're going to notice something here. There are 2 points on the graph at x equals 1. That means there's going to be 2 tangent lines. One down here and one up here. So they're asking us for the blue equation and the fuchsia equation. But this point here, we got to figure out the coordinates of that point. That coordinates I can figure out 1 and 0. Well, it looks like it. I guess it could be like 0.0001, but we need to calculate that. So how do you figure that out? We're given this equation. And we know x is 1. So if we plug in 1 for x, we should be able to solve for y. So we get 1 plus y squared minus y equals 1. Subtract 1 from both sides, we get 0. Then we factor. And if that equals 0, then we have a true equation. And if that equals 0, we have a true equation. So we set each factor equal to 0. And we have our 2 points where they touch. So we know 1, 0, and the other one is 1, 1. So those are our 2 equations. Now, because I know those points, I'm almost done. So if I use this point, I get this. Y minus 1 equals x minus 1. And all I need is the slope right there. And then if I use this one, I'm going to get y minus 0 equals x minus 1. I just need the slope at that point. So here we go. How do I find the slope at, let me make this prettier, at 1, 1. How do I find the slope? You should all say the derivative tells me the slope. So I need dy dx. So I have x plus y squared minus y equals 1, and I want dy dx to get the slope. So we know y is a function, x is our variable. Therefore, that y and that y, both of those are functions. Think of it as f of x, not just y. Derivative of x, that's easy. That's just 1. What's the derivative of box squared? It's 2 box to the first, 2 box to the first, times the derivative of box, which is dy dx. And then, what's the derivative of y? Well, clearly the definition of that is just dy dx. And the derivative of 1 is 0. We're going to do what we did on the last problem. We want to isolate dy dx. So I'm going to subtract 1 from both sides. And that gets me 2y dy dx minus dy dx equals -1. I'm going to factor out the dy dx because both terms have it. If I take that out, I'm left with 2y minus 1. I'm almost done. I divide both sides by 2y minus 1. I get -1 over 2y minus 1. There is my derivative. So here's the question. How do I find the slope at 1, 1? Well, the derivative tells me that. So this is notation you have to understand. dy dx at the point 1, 1 equals. And so I put 1 for x and 1 for y. You're going to say, but there is no x. That means I don't have to plug it in. All I do is plug in 1 for y. And what do I get? -1, 2 times 1 minus 1, -1 over 1 equals -1. So that means at 1, 1, the slope is -1. So I come back up here. So at 1, 1, we found the slope is -1. So I put in -1, and there's my equation. And that makes sense. This is a negative slope. It's going downwards. It better be negative. Now I do the same thing for 1, 0. What's the slope at 1, 0? dy dx at the point xy, which is 1, 0. Well, for that y, I plug in 0. So I'm going to get -1 over 2 times 0 minus 1. -1 over -1 is +1. So the slope at 1, 0 is +1. So the slope right here is positive. So down here, I put a slope of +1. There is my other equation. So there's actually two equations in that situation.